As you can see it here that right now we're in our studio and we have set our working directory. In our working directory, we have one data set having the heights of the males in the population. This data set is named as males_data.csv. To perform the z-statistics, let's first load this data set. To load this data set, let's create a variable named sample_data. After defining the name of the variable, let's give the sign of equality in R or the operator function in R, which is this one. After typing this, let's use the read.csv function to read our CSV file. After writing this piece of code, let's hit the run button or press the Ctrl-Enter key. Once you will do that, then look at the console. Our code has been successfully executed. And also look at the environment. In the environment, our dataset has been loaded. In the environment, you can see that there are the 2 variables and the 10 observations. And what does it mean by the 2 variables and the 10 observations? The 2 variable means that there are the 2 columns and the 10 observation means that there are the 10 rows. Now, let's check the structure of this dataset. To check the structure of this dataset, we are going to use the str function. After typing this piece of code, let's run it. When you will run it, then look at the console. In the console, you can see that there are the 2 columns. The first column is a male ID, while the second one is height_centimeters. Both are the numeric columns. Now we have told you one thing, that your data distribution in case of the t-test should be normal. So it would be wise to check the distribution of our data in which we are interested. Last time, during a z-statistics practical, we have built the histogram. This time, we are going to build the density plot for you. We have already explained it to you in the previous video tutorials that how you can build the density plot by yourself using the R-based functions. So let's write this piece of code to build the density plot. This code will begin with the word plot. After the plot, we will give the parentheses, and within the parentheses, we will write down the density. After writing down the density, we will give the parentheses, and within the parentheses, we will define the name of the variable which is holding our data. And the name of the variable is sample_data. After typing the name of the variable, sample_data, now we are going to define the column that is holding our data. So to define the name of the column in which we are interested, we will give the $, and after giving the $, we will select the column name in which we are interested. After writing this piece of code, come out of the parentheses and run it. When you will run it, then look at the plot section of your RStudio. In the plot section of the RStudio, you can see the density plot of your data. Now by looking at this density plot, we can say that this is going to have a normal distribution. And if it is going to have a normal distribution, it means that we can apply the t-test on it. Let's go and let's apply the t-test on it. To apply the t-test, we are going to create a one variable named test. After creating a name of the variable test, we will give the sign of equality and we will use t.test function. After typing t.test function, we will give the parentheses. And now this is time to define our data in the code. To define our data in the code within the parentheses, we will type x and then we will give a sign of equality and then we will write down the name of the variable in which we are interested. We are interested height_centimeter variable. Now to specify this variable, we will write down the sample_data and then we will give the $, and we will select the name of the variable or the column. After typing this, we will give a comma and then we will write the mu. Here we are going to define our population mean. Do you remember what was our population mean in the last example? The population mean was 175 centimeters. So we will type here 175. After typing this, we are going to type alternative to define the type of the test which we want to have. So we are going to type alternative. After typing the alternative, we will give the comma inverted comma, and within a comma inverted comma, we are going to type 2.sided. Why we are going to type the 2.sided? In a one sample t-test example, we have already defined the alternative hypothesis. And what was our alternative hypothesis? That the sample mean height is not equal to the population mean height. And that's why this is going to be the two-tailed test. Now you may be confused here that why we are not going to define the standard deviation here. We have defined the standard deviation of a population in case of a z-test, but why not here? Please don't worry. In case of the t-test, there is no need to define the standard deviation here. The code will automatically get the standard deviation using the sample data. We hope so that this point will be clear to you. Now, if you want to perform the t-statistics at 95% level of confidence, then this piece of the code is quite enough for you. But if you want to change the confidence level, then you have to give a comma and then you have to type conf.level. Then you will give a sign of equality, and after giving a sign of equality, you will define your confidence level or the level of significance. Let's say that we want to perform this time this t-test at 0.99 or the 99% confidence level. So we will write 0.99 here. After typing this piece of code, let's run it. We hope so that you will be very comfortable to run this piece of code by yourself by hitting the run button or pressing the Ctrl-Enter key. So let's run it. When you will run it, then look at the environment tab. The test statistics has been successfully performed. Also look at the console. Are you finding any error? No. It means that our code is successfully executed. Now let's print the results. To print the results, we will type print. We will give the parentheses, and within the parentheses, we will write down the name of the variable where our test statistics is stored. And the name of the variable is test. So let's type the test here. Come out of the parentheses and let's run this piece of code. When you will run this piece of code, then look at the console. And in the console, you are going to have the values. Now, let's interpret the results. If you look at it here, then the calculated t-value is minus 7.3274. But the degree of freedom is 9. And the calculated p-value is 4.433 multiplied by 10 raised to power minus 5. Now, by looking at these values, what you can assume? Your null hypothesis is rejected or accepted? Obviously, our null hypothesis is rejected. Why? Because 4.33 multiplied by 10 raised to power minus 5 is quite low as compared to our set alpha value. And what was our alpha value? If you subtract 1 with a 0.99, then you are going to have an alpha value of 0.01. So our calculated p-value is far less than our set alpha value. It means that our null hypothesis is rejected. We hope so that this point will be clear to you. In our next video tutorial, we will explain you about the two-sample t-test. So please stay with us.